Okay, 8th graders, we're going to start chapter 6. And in chapter 6, we're going to be doing a lot of graphing. We're going to be talking a lot about graphs and something specific called the slope. Okay? Now, I give you a definition of slope, or rate of change. And what is the rate? What does that refer to?
Rate is how steep the line is.
Okay.
And the rate of change is how much it changes.
Yeah, exactly. So we're talking about a line on a graph when we're talking about the slope. And the rate is the number of how it changes, how fast it changes, how steep the line is. So for example, from 4 to 10, it changes over the course of 5 to the right, it changes from 4 to 10. That's a rate. And so we can look at these 2 points, 0, 4, and 5, 10. And using those points, you can calculate the rate using this formula. Okay? Yep. So look at this formula.
Yes.
The slope is equal to the difference in the dependent
Variable.
Yep. Over or divided by the difference in the independent variable. Or it's often written as the change in the y. This is the change in the y over the change in the x.
So
Okay? Y over x. Yep. Now the difference in the y's. So it goes from 4 to 10. The difference is 4 minus 10, or 4 plus negative 10. Okay? And the difference in the x's, from 0 to 5. 0 minus 5. The difference in those two numbers is negative 6 over negative 5, which you'd simplify to 6 over 5. Or 1 1/5, or 1.2. Okay? So the slope from here to here is a positive slope. How do you know it's a positive slope? What does a positive slope look like? Going up and to the up and to the right. A positive slope always goes up and to the right.
And a negative slope
Okay.
goes down and to the left.
No, down to the left would mean
That would mean that's still positive.
it's still positive. Yep.
Okay, down
Yeah.
and to the right.
Bruh.
Down and to the right would be a negative slope. Yep.
Okay.
All right.
But I had the
What
right
about from
idea.
A to B? Look at
Yo-yo.
A to B. The slope of line segment AB. Okay? So, using these points on the graph, 10 to 10 is the change in y, over 5 to 12, the change in x. What do you get?
0 over
0 over negative 7, which you can simplify to just
0.
0. So look at this line. What is the slope of this line?
0.
0. It changes 0. The change in the y is 0. And any horizontal line is a 0 slope.
Yep.
Any line that's a horizontal line is always a 0 slope.
Is that the same thing
Okay.
for vertical lines too?
No, look at what it says for vertical lines.
Oh, I see.
Vertical lines give you what's called an undefined slope. Okay? So, let's go back. Positive slope always goes up and to the right. A negative slope always goes down and to the right. And you can think of slope as the rise, the difference in the y, over the run as it goes to the right. What does it look like as it's going to the right? That's rise over run. Okay? Isaac.
So like I didn't see at first, but now, like I get how when it goes down to the right, it's like those charts when like that phrase like it went through the roof. like for a company, their sales have gone higher and higher and higher.
Yeah.
And
Right, that's the rate of change, isn't it? It's growing, or it's a
Yeah.
positive slope, okay? Now, let's go back to, rise over run, and let's talk about something called the slope formula. I'm gonna write that, we're using that in this, so I'm gonna write it right here.
should you erase the trouble on
The formula for slope. So write this down,
Writing it down.
okay? y2 minus y1. In other words, the second coordinate of y minus the first coordinate of y over the second coordinate of x, so x2 minus x1. This is the formula for y, or for the slope. Okay?
Wouldn't that pretty much just equal y over x?
The change in the y over the change in the x. Yep. Yep. But there's a certain order that you have to do this in. Okay? In other words, we have to, if we subtract -1 of this point, if we're going to find the slope of these 2 points, point A and point B, if we subtract -1 minus 2, then we have to subtract and go back up to the first point again and subtract them in the same order. -3 minus 0. You can't do -1 minus 2 and then 0 minus -3. That's a different order. You have to subtract the points in the same order, which is why they put a little 2 and a 1, and then 2 and a 1. Shows that that's an order. Now, it doesn't matter which order you use, really. You could do a 2 minus -1 and 0 minus 3, and you get the same answer. The important thing is that you always use the same order when you're subtracting the y's and then subtracting the x's. Okay? Bailey,
Yes.
you're not focused here.
But I'm drawing the graph that you wanted us to draw.
No, just listen for now.
Okay.
So you're focused up here. Okay? Now, so write this example down. -3, start with writing down point A, -3, -1. Bailey?
You
Christina?
just told me to listen.
Yeah, listen.
Yeah, you told me to listen, and then you had my undivided attention, and now you want me to go back to the notebook so I can write stuff down so that you can yell at me again for not being focused on the board. I just think that's pretty funny.
Okay, I'm not yelling at you, I'm just
No,
wanting you to make sure that you are following along with the notes.
Yes, you were.
I didn't know what you were doing because you
No,
were,
I was.
you were
drawing-
focused on something else.
Yeah, I was drawing
Okay.
the graph. See, this is the
Oh,
graph.
you don't need to draw the graph. Just use graph paper. Or use a sketch in your notes, okay? Otherwise, it's going to take way too much time to draw out a coordinate
Like
point.
10 minutes.
Okay?
Okay.
So, write this down. Point A, -3, comma, -1. Write that down.
Formula. What's that spell?
Point A, -3, -1. And point B, 0, -2. Sorry, 0, +2.
I remember this from class. This was not fun.
Now, Bailey, stop talking. Listen. Now, write down these points into the formula. That's what I wrote here. So -1 minus 2. Write this down. Stop talking. -1 minus 2.
It's maybe free, but like just for solving problems' sake, can we just put -1 plus -2?
Yeah, that's what I was just going to tell you. -1 minus 2 is the same as -1 plus -2. Okay? Remember, when you're subtracting, you should insert a plus sign, so you add the negative. Okay? Change subtraction to plus negative.
There's a lot of minuses in this
Now,
equation.
subtract the x's. -3 minus 0. And make sure that you subtract them in the same order. Okay, Keisha, are you following along with me?
We're all following along.
I was talking to Keisha. So, when you simplify this, you have -3 over -3, which you should simplify to what?
One.
What's -3 over -3?
-1, yeah.
Positive 1.
One.
Positive 1. What does a slope of positive 1 mean?
That is
Slope,
right
yeah.
above -0.
Slope is usually written in fraction form, okay? Because you have to have a change in y over a change in x. So a slope of 1 is sometimes written as just 1 over 1. What does 1 over 1 mean? How would you describe that on a graph?
Just keeps on going up one and then over.
Yeah, for every one that you go up, you're going 1 over. Okay? Up 1 over 1.
So like this.
Okay? So look at this graph. Now from A to B. These are two of the points on the graph. Another way to figure out the slope of this line, if you're given the line, is to count. Here's how you count. You count the rise, meaning that you count up or down from one point to the other, and then you count how far over it is, because it's called the rise over the run. Okay? So the rise from A to B, it goes 3 up. So it's a change of 3.
It's 33.
And from there, if you count over to B, it's over positive 3. So it's 3 over 3.
Mr. Motsky,
Okay? Yes?
I'm trying to participate as much as I can and write down notes and follow along and stuff. But apparently the orange on top of Dylan's head is very distracting to Christina, and her laughing is very distracting to me.
All right. Do you have all these notes copied?
Yeah.
Okay. So just, you're paying attention?
Yeah.
Christina, if you're distracting her, why don't you move over here? Okay?
Yeah.
Then
No,
Dylan-
she's not.
Dylan-
She's
Now
not.
you're
Now-
not distracted? Okay, good. Isaac?
Alright, so
Glad
pretty
it's
much
been
instead of
opposite.
like counting, like there's another way of doing it, like going up 3 and over 3. Couldn't you just go like diagonal and stuff up and sideways? Because if you go like diagonal, that's 1 sideways, 1 up. So you
Right.
can do it like 3 times and like, whoa, it's 3, 3.
Yeah, the problem is that sometimes,
They're not.
with what you're saying, sometimes the line that you're counting is not, doesn't go through a point every time it crosses the line. So that's why you could, in this one, since it goes up 1 and over 1, and that lands right on a whole number point, that works. But what if it goes from here to here?
Well, I'm not saying you have to do it every time.
Correct, and that's what I'm just trying to say, is that if it doesn't go through any points, then you're gonna have to count up and over to the next point. Okay?
So Mr.
So you're always
Motsky,
counting up and over to the next point.
if you had something like 8 over 6, so you would go up 8 and then you would go over 6.
Yep.
If those are whole numbers, would those always go to a point?
Yes, they would go through those points, and it would keep going through
Well,
those points.
Yeah, I'm saying would the line always add up to points instead of going? No, it would. Never mind. Okay.
And you could reduce it to 4 over 3 if it was 8 over 6.
Right.
And it would also go to those points.
Yeah.
Look, you notice on this graph, it always goes up 3 and over 3, up 3 and over 3,
Yeah.
or up 1 and over 1, up 1 and over 1 as you're following the line.
Yep.
Okay? Now, I also point out here that you can count down and to the left
Yeah.
to get this to the same points.
It's like stairs.
Remember, if you're counting down, 1, 2, 3, that's a negative 3. And from there, if you're counting to the left, 1, 2, 3, that's also negative 3.
So it looks something like this.
And negative over negative is positive also. You get the same slope, whether you count up and to the right or down and to the left. Yes?
Can you go back to the other page, like with, like A, then to B with the, what's it called? 1, 0, the, like the A to B and 0.
A to B and, yep, here.
No, go back. Just go back one page. The, okay, yeah, the,
Horizontal line.
yeah, so, something with that, like it goes to A to B to C, it's going up. So
From B to C.
what if it goes to C to D and D is down? Would you put like, I guess,
So it went down like that.
-3 and minus negative 8, I guess. Would you make add instead of subtract?
Yeah, let's do an example. Okay, there's one in your book on page 310. It gives you a line and it gives you these points. For point A, -3, 2, and point B is 3, 1. Okay? So, you could either use the graph and count, or you could use these points and use the formula and subtract them.
I don't know if it's just
2
me. but-
minus 1,
I don't know if it's just me, but it sounds like a goose is dying somewhere downstairs.
It's called
Okay.
practice.
Focus.
Oh, okay.
focus on this, page 310.
I don't think this is what I meant.
Wow.
Oh,
Like the
where if it
one-
had 3
the
minus
one.
-3?
Like the 1 is negative, so there's 2, and then minus
Two negatives?
1.
So
But
if you
you
had,
say 2 plus 1.
correct. Let's reverse the
There.
order. I think I know what you mean, Isaac.
Yes.
So if you reverse the order, and you did 1 minus 2 on the top, and then you did 3 minus -3.
Yeah.
Yep.
You'd add 3
Then
plus
you'd
3.
add 3, correct.
Alright.
So this would become plus, and this would be -1 over
Over
6.
6.
Yep. Okay. Yep, very good.
Uh-huh.
As long as you keep the same order, you can get the slope either way.
I totally
Okay.
understand this.
All right, I want you to practice then. Go to page 313. In number 1, actually 1 and 2, they give you the information in a chart. Okay? So the chart is of time and temperature. We're going to find the rate of change in temperature. So, if the points are 1 and 4, it was -2 and then 7 degrees. What is the rate of change? Time is in hours.
2.
don't guess.
No, I'm not guessing.
Alright,
It's plus 3
But the
No, no,
rate
no.
of change is what?
time
minus
plus
negative 3.
3.
So let's write this down. Let's figure this out.
Time plus 3.
So if you subtract them in this order,
It's pretty much time is x and temperature is y.
right?
So pretty much time plus 3 equals temperature.
Well, no, we're gonna find the rate of change in this, okay? We're gonna find the slope, the rate of change.
Okay, never mind. I was thinking of
Okay.
something different. I'm sorry. I was thinking of something totally different.
Right, so we're gonna use this to find the rate of change,
Yep.
okay?
Yeah.
So for
That's
the change in y, it's -2 minus 7. And the change in x is 1 minus 4. So this is -9 over -3, which is a change of 3 what?
1/3. 3 1/3.
No, 3 over 1, but what are the labels?
You mean like negative?
Time is the, temp is the one up top.
Yeah, so this is 3 degrees per
Ah.
hour, per 1 hour. And is it going up or down? It's going up. It's a positive slope.
But
So the
then-
temperature is rising at a rate of 3 degrees per hour.
But then it changes.
Okay.
7, time is 7, and then temperature 16.
Mm-hmm. And is that 3 degrees per hour? It's not?
Wait.
So from 7 minus 16 over 4 minus 7 is -9 over -3, isn't it? So it's still 3 degrees per hour. Right? Isn't that what it shows on the chart, Isaac?
Yes. So I was right. It's sort of, kind of, yeah. It has something to do with 3.
So it's pretty much. Still need to.
So this is what you would write. Temperature is rising 3 degrees per hour.
So can't you multiply it, get it?
Or it could be 6 degrees for every 2 hours.
Like 7 times 1 hour and then 16 times 3.
I'm not sure what you're doing, but we're finding the rate of change, okay? Okay,
Okay, now I see it. Alright.
okay.
Eh,
What would you do with number 3? How would you find the rate of change with number 3?
let's see now.
Christina?
What point does it go through?
Yeah, Christina.
Alright.
How do you use that line to find the rate of change?
Wait, what'd you get?
When it goes
You
through.
go down one, blah, blah, one, down
Yeah,
one, blah, blah,
Christina.
one.
How do you use the line rendering shape?
Let's see now.
Huh?
It's at 0:15.
What you have to do, Christina, is you have to find
And it goes to.
You have to find points on that graph that are whole numbers that we can use to find the rate of change. So is 0, 15, is that one of the points?
Yeah, 0:15.
Isn't that the starting point? Let's use
Yep.
that.
Yep.
Okay, so point A will make 0, comma 15. Now pick another point.
150 and then 5, yeah.
150, comma 5.
Mhm.
Okay. And so 5 is,
Gallons.
all right.
15 is also gallons. So
So then subtract.
150 minus 0 and then 5 minus 15.
You have to use the same order.
Yeah.
So 15
Wow.
minus 5
So
over,
Then you have to do b minus a.
well, you can do b minus a, sure, we could go that way.
150 minus 0, because you can't do 0 minus 150, right?
You can do either one. You can do
You
either
said you
one.
couldn't do that.
As long as you keep the same order that you are subtracting, you can use either point. So if we start with 5 minus 15 over
150 minus 0.
150 minus 0, that equals
Negative 150. 50 is on the bottom.
negative 10
Over negative 1.
over positive 150.
Positive. Oh, right. I'm thinking of 0.
Okay,
Minus 150.
so reduce that to,
Let's see now.
you just cross out the zeros, right? So it's a rate of change as,
150.
yep,
Negative 150.
negative 150.
So,
Now this is a tank of gas,
okay, so the gap.
and the amount of fuel being consumed is 1/15 of a gallon for each mile.
Negative 1.
Now I want you to do the evens: 2, 4, 6,
8, and
8,
that's it.
10, 12, 14, 16, 18, and 20. Okay. So 2 through 20 evens for tomorrow.
Okay, let's see if we can